In this video tutorial, I'll be going over the method with which to calculate all the relevant dimensions for a set of gears. That would be for a pinion as well as the corresponding gear. We will be looking at filling in all of the details in this table through a series of calculations that define each of these different dimensions based on ratios for that particular gear set. So the first and most important piece of information that we have in this case is the gear ratio. In this case, we're looking at a ratio of 2 to 1. That 2 to 1 ratio means that our pinion will be spinning at twice the speed of our gear. So if our pinion is spinning at 350 RPM, that is twice as fast as our gear is spinning, so our gear needs to be spinning at 175 RPM. Next, we'll look at the module. Now remember that any two mating gears need to have the same module. So in this case, our module of 4.23 for the pinion will be the same for our gear. We'll then look at the pitch diameter of the pinion. The module of your gear, given by M, is the pitch circle diameter divided by your number of teeth. So it's the ratio of your pitch circle diameter to the number of teeth. We know what our module is, and we know what our number of teeth is. So we can, from this, work out that our pitch circle diameter is equal to our module times our number of teeth, and that's going to be 4.23 times 20 teeth. That will give us a pitch circle diameter of 84.6 millimeters. We can fill that in the table as 84.6. Then if we have a look at the corresponding entries for our gear, our number of teeth will be twice as many teeth because we have a gear ratio of 2 to 1. So we'd have 40 teeth on our gear. So our gear is spinning at half the speed but has twice as many teeth. If you have more teeth on your gear compared to your pinion, your gear will spin slower than your pinion. We can then calculate what our pitch diameter would be for our gear based on our gear module and our number of teeth. We just multiply those two values, and when we multiply our 4.23 by 40, we get a pitch diameter of 169.2 for our gear. When looking at the next four entries in our table, the addendum, the dedendum, the hole depth, the clearance, and the outside diameter, and only the clearance, these four here. When looking at those dimensions relate directly to the teeth of the gear. Now, because each of these, the pinion and the gear, have the same module, the teeth are going to be the same size, which will allow them to mesh. So if we look at our addendum, your addendum is just equal to your module. So we can say that HA is equal to M. Our dedendum, HF, is going to be equal to 1.25 times our module, and our hole depth is just the sum of those two. So your hole depth is equal to your addendum plus your dedendum. If we have a look at the sketch here, we can see that this distance is your dedendum, your distance from the root of your gear tooth to the pitch circle diameter, and the remaining distance from the pitch circle diameter to the top of your gear tooth is your addendum. The sum of this distance and this distance gives you your hole depth. So we know that our addendum is just going to be 4.23 and 4.23. Our dedendum is going to be 1.25 times that value, so we'll have 1.25 times 4.23. and that'll give us 5.2875. I'm going to round off to 2 decimal places, so we're going to have 5.29. We then have our whole depth, so we're just taking this number plus that number, which is going to be 4.23 plus 5.29 and leave us with 9.52. And again, these dimensions relate specifically to the gear teeth, so they are the same for both your pinion as well as your gear. When it comes to the clearance, we are looking at the distance between the tip of your gear tooth and the root of the corresponding gear in the gear set. That distance will be the difference between this distance, which is your addendum, and this distance, which is your dedendum. So we're simply subtracting our addendum from our dedendum. So then our clearance is going to be your clearance will be your dedendum, HF, minus your addendum, HA. So what we get is 5.29 minus 4.23, and our answer is 1.06. Now, for the last 3 remaining unknowns, they are all going to be different for the pinion. Well, no, the outside diameter and the root diameter will be different for the pinion and the gear, and the distance between centers will be the same for both of them. Now, your outside diameter is just going to be your pitch circle diameter plus 2 times your addendum. So your outside diameter is equal to your pitch diameter plus 2 times your addendum, which is HA. So in this case, that'll be equal to 84.6 plus 2 times 4.23. And this leaves us with a value of 93.23. Sorry, 93.06. So we can write in there that our outside diameter is 93.06, and we can then complete the same calculation for the gear, which is going to be your pitch diameter, so 169.2 plus 2 times your addendum, which is the same, 4.23. And that will give us an answer of 177.66. Then we come to the root diameter. So the root diameter, similar to the outside diameter in calculation, but in this case, your root diameter, so this diameter here is going to be equal to, so RD will be equal to your pitch diameter, but in this case we're going to subtract 2 times our dedendum, so our HF value. So for the case of the pinion, our pitch diameter again is 84.6, and we're subtracting 2 times our dedendum in this case, which is 5.29. So we end up with a final answer of 74.02 millimeters. And if we want to double check that, we can add our hole depth to our root diameter, and we should get our outside diameter. We then perform the same calculation for our gear, which is then going to be the pitch circle diameter, which again is 169.2, and we then subtract 2 times our dedendum, which again is 5.29, and we come to 158.62. Now finally, to calculate the distance between the centers, remember that the gears make contact along the pitch diameter. If contact is made along the pitch diameter, that means that the distance between the centers of the gears is related to that pitch circle diameter. So if we have a look at 2 meshing gears where the line I've drawn is representative of the pitch circle diameter, the distance between the centers is just the sum of the pitch circle radius, or the pitch circle radii. In other words, half of your one pitch circle diameter plus half of your other pitch circle diameter. So our distance is equal to our pitch diameter of our pinion divided by 2 plus our pitch diameter of our gear divided by 2. That'll be the same obviously for our pinion and our gear, and that pitch diameter is just going to be 84.6 divided by 2 plus 169.2 divided by 2, and we end up with 126.9 as the distance between the center of our gear and the center of our pinion.